All right, welcome to video 3 of week 11, where we are going to discuss parallelograms, rectangles, rhombi, and squares. That's a lot, but they all have very similar properties to each other with some small differences, which kind of makes sense based on our definitions of them. So let's take a look at a parallelogram, and we'll talk about its properties. So we have this parallelogram, and let's call it parallelogram KATY. We know that the lines are parallel because that's the definition of parallelograms, that the opposite sides are parallel. Which means, just like with our trapezoid, we will have our consecutive angles are supplementary. So same idea, right? We have parallel lines, so we can make the same side interior angles. So we know angles on same side are supplementary. That's actually going to be our first property right away because we have those parallel lines. Another property comes from our diagonals, which we said we connect opposite angles, right? Here we have a triangle on the top and the bottom of our diagonals. We could do a lot more information here. Now that we have this diagonal, we can form from some z's and form alternate interior angles. After all of this, we would get the fact that this yellow triangle is congruent to the blue triangle, which just means that we have some interesting things going on elsewhere in our triangle. First thing means opposite angles are congruent. And that's because we have those parallel sides. Also in a parallelogram, we have, because of those congruent triangles, we have congruent sides. So opposite sides, and they look like that too, right? Opposite sides are also congruent. So we're getting a lot of congruent things in our parallelogram. The last thing, we have to draw our second diagonal, which I did not do a good job at. Our second diagonal. Maybe I'll clean this up a little bit. If we draw our second diagonal, we see now, instead of 2 triangles on the inside, we see 4 triangles on the inside. And we know all this information. So what we can say is these 2 yellow triangles are congruent to each other, which would mean this side is congruent to this side. This part of our diagonal is congruent to the other half of it. So we can also say that diagonals bisect each other. All right. So that is a lot of great information. We are going to see some practice problems in the video that explores what happens when we do all this. But also, if we look at it, it also means, if we look at these 2 yellow triangles, right, and we can see this because of our 2 parallel lines, that this smaller part of the angle forms a Z with this angle down here. So we know that these angles are also congruent, which might show up, but it's not going to be one of our properties. So let's copy these 4 properties onto our Freyr model. So we have, let me zoom in. For all parallelograms, our first thing said, angles on the same side are supplementary. Then we drew the diagonal. We saw that we had two congruent triangles, so then we said opposite sides are congruent. We also said opposite angles are congruent. And then lastly, we said, once we draw both diagonals, right? Both diagonals bisect each other. So let's actually take a closer look at these and see some examples of how we use those properties with numbers. So let's say we have this parallelogram. We have both of its diagonals drawn, and we know pieces of those. So let's just call that point E. We know that DE is x plus 1. EB is 3x minus 13. We know AE is 2y, and then we also know that EC is y plus 5. So we have both diagonals drawn. The only property that talks about both diagonals is the fact that they bisect each other, which, if we remember, bisect means they're perfectly cut in half, and halves are equal to each other. So to figure this out, we can do, where's my highlight? This half has to be congruent to that half. So we have 2y is equal to y plus 5. So subtract y on both sides, we get y is equal to 5. Plug it back in, we get 10 and 10. So the entire diagonal here is 20. Let's try that for the other diagonal. We have the left is equal to the right. So we have x plus 1 is equal to 3x minus 13. Subtract x on both sides. This one's a little bit longer of a process. Plus 13 on both sides. 14 equals 2x. Divide both sides by 2, so we get x is equal to 7. That's not our final answer. We can plug it in, though. We have 8. Nope, we don't. We have 6, right? 7 minus 1 is 6. And then we have 3 times 7 is 21. 21 minus 13 is 8. That was x plus 1. Okay, so that was 8. All right, so both sides are 8, which means the whole thing, dB, is equal to 8 plus 8, which is 16. So that's infuriating that it wasn't drawn to scale. But it's true. So let's move on to our next example. Here has a lot of information in it. We have a parallelogram WXYZ. We know that this angle up here is B plus 15. This angle down here is 2B. Then we know the whole side WX is 4A plus 10. And then XY is 6A. So let's try to figure out as much information as we can. So let's start with the sides first. If we look at our properties, it said, oh, the first property, angles on the same side are supplementary. So let's see if we have that. Do we have angles on the same side? And in fact, we do, right? B plus 15 is on the same side as 2B. So these are supplementary, which means we add them together and set it equal to 180. So we get 3B plus 15 is equal to 180. We get 3B is equal to, since we have to subtract 15, 3b is equal to 165, and if we divide both sides by 3, we get b is equal to 55. So if we take this further, we have to then plug it in. So we have 2b times 55, sorry, 2b, so we do 2 times 55, so that's 110. And then hopefully it works out. Once we do 55 plus 15, we get 70, and those two add up to 180. So we have angle x, we have angle y. Can we figure out the other angles? And the answer is yes, right? One of our properties says opposite angles are congruent. So if we're looking at W, we need to say what angle is opposite from it. So we go across the shape and we get to Y, which is 110. We could also see because these two angles are both obtuse, right? And then that means this other one is 70. So we found all the angles. Now let's see what we can do with our sides. So if we look at this, we have that 4a plus 10. And the only property from our notes says opposite sides are congruent. W, Z, and X, Y are opposite, they're congruent, which means we set them equal to each other, and then we can solve for our variable. So we get 10 equals 2a, so a equals 5. We plug that back in. We get 4 times 5 is 20, plus 10 is 30. And then 6 times 5 is 30. So we get it. The only thing we can't figure out are these sides. There's no way to do it. So it's just going to have to remain an unknown. So that's what we can do with parallelograms. I also said we're going to go over rectangles, rhombi, and squares. And they all have just small extra information on top of what we already know about parallelograms. So for a rectangle, it's a parallelogram with 4 right angles. So that means it has the same facts about parallelogram. Those 4 stay the same, but it also has a other fact that's true about it. And that's because of the special property that the rectangle has right angles. That means the diagonals are going to be something. So let's take a look. Let's try to think of it on our own first. Let me draw a rectangle. All right, we have 4 right angles. Everything's still true. Opposite angles are congruent. Opposite sides are congruent. Diagonals bisect each other, but once we draw our diagonals, because it has those 4 right angles, our diagonals are congruent. So let's add that. Diagonals are congruent. So let's see what new way can we use that information. Yeah, I'll come up with a problem on my own then. So let's say we label this RECT, and I say RC is equal to 5x minus 7, and TE is equal to 3x plus 1. So RC is this diagonal, TE is the other. We know in a rectangle the diagonals are congruent, so we can actually set these equal to each other and then solve for x. So minus 3x on both sides add 7 on both sides, divide by 2 to get x equals 4. Not quite our final answer. We have to plug it back in. So we get 13 and 13. So both these diagonals are 13. We could also do a lot more information with the rectangle because it's still a parallelogram. So like this side might be 12, which means the other side must also be 12. If this side was 5, that means the other side must be 5. We know opposite angles, right, are all 90. And then we also know that each half, and these are perfect halves, are all 6.5, and they all match each other. All right, so that's what we can do with rectangles. Our next shape is a rhombi, which is a parallelogram with 4 congruent sides. So again, it's going to have the same facts as a parallelogram. And then it's going to have 2 more that are different from a rectangle. That's true only about rhombi. And let's try to draw our own rhombus, and we can try to see what's going on. Okay, so here's a parallelogram. We also know that all the sides are congruent. So let's draw our diagonals and see what happened. So if we look at this rhombus, the diagonals, just like in a kite, are perpendicular, which kind of helps us out. We won't really have too many problems because the answer right away will just be 90. The more interesting thing here is because all the sides are congruent, we have a lot of symmetry in this shape. So that means these right here, right, all of the corners are all getting cut in half because we have all these congruent triangles inside of our rhombus. So let's go back to our Freyer model. Fact 5, on top of the additional ones from the parallelogram, says the diagonals are perpendicular. The other one said each vertex angle, which is just our fancy word for saying corner, is bisected. So you might see a problem where I just give you 1/2 and we have to figure out some information from it. Okay, so let's look at a practice problem. If we have another parallelogram, let me try to draw this one crazy. Okay, parallelogram, because I'm sorry, rhombus, because we have all congruent sides. We're going to call this one Utah. And in Utah, we can draw the diagonals, and then we're going to call this point P. So what if I said the measure of angle UPT is equal to 4x plus 18. We want to try to solve for x. We have to remember in all rhombi, in every single rhombus, that middle angle, because of our special properties, they are perpendicular. So that means that angle for sure is 90 degrees. So we can actually solve for x now by subtracting 18 on both sides and then dividing by 4 to get x equals 18. So that's just solving for x. What's a little bit more interesting here is what happens on the smaller angles inside of it. So what if I said This angle right here is 8x plus 2, different x. So let's say 8y plus 2. And then we say this one over here is 10y minus 10. So we have to look at our properties. We know this is a rhombus. We're trying to think to ourselves, what can we do? And the answer is that sixth property of a rhombus, the vertex angles are bisected. So that means this angle is perfectly cut in half by that diagonal. So that means 10y minus 10 is the same size as the other side, which is 8y plus 2. So we can solve for y by combining like terms. Dividing by 2 to get y equals 6. We can plug that in to actually figure out how big these angles are. We get 48 plus 2, so that's 50. We have 60 minus 10, so that's 50. So then this entire angle is 100, which is not drawn to scale, right? Which then we can use all of our other properties to figure out more information. T has to be 80 because angles on the same side are supplementary. H has to be 80 because opposite angles are congruent. A and U are congruent to each other because this is a parallelogram. So U is also 110. We have all of this great information happening because we have all these great properties. The last shape we need to talk about is our square. It's a parallelogram with 4 right angles and 4 congruent sides. So it's a parallelogram, which means it has the same facts as a parallelogram. It has 4 right angles, so it has the same facts as a rectangle. It's also 4 congruent sides, which means it's also a rhombus, so it has the same facts as a rhombus, right? So it has a lot of information, which means if we have a square, right, the opposite angles are congruent because they're all 90. Opposite sides are congruent because that's the definition of a square, right? If we do the diagonals, we know they bisect those. So this is 45 degrees, 45. They're all 45, which just makes sense because it's a square, right? We know that these in here are 90 because it's a rhombus, so the diagonals are perpendicular. We have all this information because it's a square. It has all this information is already true about it, no matter how big the sides are. So everything in our Freyer model is filled out for these 4 shapes. We saw examples of how we can use this information to solve our unknowns. And we saw how much of an overlap there is between parallelograms, rectangles, rhombi, and squares, because rectangles, rhombi, and squares are just special types of parallelograms. So that's it for this video. I'll come back with the 4th video, your final video of week 11, which will just be what happens if I give you a shape and I ask you to classify it. How do you do that? All right.